So good evening. Is audio clear? Yeah. Are you able to hear me? Yeah. So welcome to the new chapter here or new lesson uh, on geography optional. And see, we have started the series of some important topics to be covered for geography optional for UPSC mains. I have done um, one concept in the morning YouTube session. So you can just subscribe to this channel, that is UPSC Unacademy Live UPSC. This is now an exclusive channel for UPSC preparation on Unacademy, and here you will have almost all the educators of Unacademy that who will be teaching you the live classes on YouTube. Okay, so we will try to cover most of the topic that are important for your uh, UPSC preparation, both prelims as well as mains. Myself, MD Rizwan, I am teaching on Unacademy Plus now. Okay, I am faculty for civil service examination, and I have been teaching for civil services last 14 years. You can follow me on Unacademy app. You can search with the name Rizwan.md, and the same is my referral code if you are going to subscribe for the plus courses. My area of expertise is geography optional, general studies, geography, ecology and environment, and disaster management. So, I am also an author for regional geography, books on regional geography. So, let us begin with today's important topic. As I told you, in this series, we are covering the important topic for geography optional subject. Now here this topic is equally important for your general studies also. This is overlapping with GS. So this the title of the topic is seismic probe of Earth's interior. Seismic probe of Earth's interior. This will be there in GS landform chapter. In GS landform it will be there. Uh, so physical geography you will be studying about interior of the earth, and seismic probe in the sense it is about the earthquake waves. Okay, earthquake waves. Earthquake is seismicity, and how how these earthquake waves can be used for the study of earth's interior, that we are trying to understand here. So, in optional, this topic is a part of the first chapter of physical geography, that is geomorphology. Okay, so the scope of this topic in optional subject is like it can be a short note, and maximum for 10 marks. Okay, you cannot expect like a big question on this like 15 marks or 20 marks, but up to 10 marks, 10 से 15 मार्क तक आप इसमें एक्सपेक्ट कर सकते हैं. Okay, so this is chapter 1 of physical geography, that is geomorphology. Now, so let us begin with, here it is about the study of interior of the earth. Okay, now we are trying to understand earth's interior. Earth's interior. And for understanding earth's interior we are going to use earthquake waves. Okay, so this is seismic waves, right? So that is, therefore it is known as seismic probe of earth's interior. Probe means investigation. Okay, investigation, how we can investigate into the interior of the earth by using earthquake waves, right? Now, before that, let us understand why it is important to study the interior of the significance of study of Earth's interior. So, for this, first thing is almost all the geophysical phenomenons that we experience on the surface. Okay, they are the product of whatever is happening inside the earth. It may be like even earthquake or volcanism, or you can say tsunami. Okay, so all these phenomenons what we are experiencing on the surface of the earth is the result of interior of the earth. Next is the endogenetic forces. Endogenetic force means, again, the name itself indicates that the forces that are originating inside the earth. Okay, the forces that have the origin in the interior of the earth, which are responsible for construction of lot of landforms. Okay, landforms, they have influence on the landforms, like the process of folding, faulting, crustal modification. This is because of the endogenetic force. This also is related to interior. The surface configuration of the earth means what is surface made up of. This also we can understand from the interior of the earth. And more importantly, what is the composition of the rock, the geological composition of the rocks, geological composition of the interior, okay, of the earth. Okay, it can help us in understanding the minerals, their formation, then their location of the ores. All this can be understood based on the study of interior of the earth. Okay, so this is the significance. For this reason, we have to understand, we have to focus on the interior. Now, the next question that arises is how we can study the interior of the earth, because if you see the structure of the earth, the radius of the earth is approximately 7,000 kilometer, and the center of the earth is having a temperature of 6,000 degrees. The temperature inside the earth increases, and the radius of the earth is such large, that is approximately 7,000 kilometer. So in such a condition, can we really go into the interior of the earth and check what lies inside? So there are two approaches. We can say that the study of interior of the earth can be based on direct evidences, and number two, it is based on indirect evidences. So what are direct evidences? Means the study of the interior of the earth based on access to interior. If you are able to get the material from inside, if you are able to get some rock from the interior of the earth, we can drill into the interior of the earth and then study. That is known as direct evidences. So here what it will be, it is like drilling, mining, then volcanism. All these will come under the direct evidences. But are they really going to help us in understanding the entire interior of the earth? The answer is no. How much you can drill? You can drill only some 10 to 15 kilometer. How much you can mine, or what will be the depth of the volcanism? It can be hardly 100 or 200 kilometers, not more than that. So the direct evidences are restricted. Okay, they are restricted. They do not give us an idea about the entire interior of the earth. They only give us an idea about the superficial part of the earth's interior. That is why we have to rely on indirect evidences. Hope you are getting this. So why direct evidences are not very much applicable in the study of interior of the earth? We can definitely use them, but they cannot provide us an idea about the entire interior of the earth, because they are restricted. They are only restricted to the upper superficial part of the earth. Therefore we have to rely on indirect evidences. Then what are these indirect evidences? And here comes the application of earthquake wave. Earthquake waves provide indirect evidences about the earth's interior. And second is geomagnetism. Geomagnetism, what is geomagnetism? This is uh, geomagnetism is the magnetic property, okay, magnetic property of earth's interior, okay, or magnetic nature of the earth. Okay, magnetic property or magnetic nature of the earth can help us in understanding the interior of the earth. So these are considered as two indirect evidences. In this lesson, in this concept, we are trying to understand how the earthquake waves can be useful for the study of interior of the earth. ठीक है. So now what are different models about earth's interior? Okay, how we can understand, or what is our knowledge about the earth's interior? See, there has been a different models that were proposed over a period. Like we have the first and very basic model about the earth's interior, that was based on composition. This was proposed by the geologist Edward Swiss. He said that earth is made up of three different layers having three composition. The outer layer is known as a sial, the intermediate layer is sima, and the innermost layer is knife. Sial stands for silica and aluminium, and silica and manganese, this is sima, and knife is nickel and iron. So this is the first basic model about the interior of the earth. Okay? Now the second model that was proposed was based on density. What is that? The density of the earth increases. Density increases with depth. Density increases with depth. The surface of the earth has the least density, and that layer is known as crust. The intermediate layer is known as mantle, and the innermost layer is known as core. Core is going to have the highest density, right? So density model is based on density of the crust is less than density of the mantle, which is less than density of the core. The core, that is the interior of the earth, is going to have the highest density, right? So this is the second model what we have about the interior of the earth. And the third one, which is developed based on the state of matter. State of matter means in what the material inside the earth exists in which state. So here we have different layers. So the outermost layer of the earth is known as, instead of crust, we have used the word lithosphere, and lithosphere is resting on asthenosphere. This is asthenosphere, which is, both are the part of what? They are the part of the crust and mantle. So we can say that lithosphere is in the solid state, and asthenosphere, which is below the lithosphere, this is semi-solid, and remaining part of mantle is what? Solid. Okay. The outer core is divided now into two parts, that is inner core and outer core. The outer core is in liquid state. Okay, so this is in liquid, and inner core is in solid. Okay, so these are, we can say, the divisions that we are having based on the state of matter. Obviously density is also considered here, but the focus is on the state of matter. Okay. So particularly this model of Earth's interior was developed based on the investigation that has been done by using earthquake waves. Okay. So if you are asking me like what is where we have used this earthquake wave, or what is the outcome of using the earthquake wave in the study of Earth's interior, we got this model, that is outer core, inner core, solid, liquid, this kind of states of matter, whatever we are studying inside the earth, this, or we have now, this is based on the study of earthquake waves. Okay. So we know that what is earthquake. If you are able to understand what is earthquake, earthquake is the sudden release of energy, sudden release of energy from interior of earth. Okay, sudden release of energy from the interior of earth. Suppose this is the surface of the earth and the energy is released here. So this point where this energy is released is known as a focus, and here this will be known as a epicenter. So we have two things, one is focus and another is epicenter. Okay, and when this energy is released, this energy is traveling in almost all the direction, and this will be traveling in the form of waves. The energy travels in the form of wave, and these waves are known as earthquake waves or seismic waves. Okay, so in this context we are having the term seismic wave. So what is seismic wave? These are the waves that are generated, okay, waves that are generated at the focus where there is release of energy at the time of earthquake. Okay, so here let us understand in better way what is seismic waves. These are the mechanical waves that require a medium for propagation. Okay, like sound waves, we can say that these are the waves which require some medium for propagation, maybe solid, liquid or gases. So there are three types of waves that are generated at the focus. So this is P wave, S wave and L wave. So what is P? P is known as a primary wave, S is known as secondary wave and L is known as long wave or surface wave. Actually, S waves are not the direct waves, they are like more a modification of the waves that has reached the surface. These waves are L waves are not coming from the focus, they are the modification of the waves that are reaching the surface. So in this way we will have suppose this wave is reaching here, so it will get modified near the surface. So whatever tremors we experience or whatever destructions are there on the surface of the earth, or you can say vibration we are experiencing during the earthquake, this is not really because of P and S, this is because of the L waves. Remember, this is very important point. L waves are responsible for the destruction, L waves are responsible for vibrations and tremors. But always being located near the surface, they are not very much helpful in the study of interior of the earth. Therefore, we can just eliminate them and say that only the waves that come from the focus are useful in the study of interior of the earth. So, in this context, we will say that P and S wave, they will help us in understanding the interior of the earth. Yes, are you able to understand this? So, let us try to understand something more about P. So, P waves are known as primary. They got a name primary because they are the first wave to arrive at the surface. Means what? Their velocities will be highest, they will be propagating with the maximum velocity, okay, maximum velocity, and they are first to be recorded on the seismograph. So we can say that the characters, how is the character of this P wave? They are like sound waves. Sound waves means they are more or less longitudinal in nature, and they can travel through all the medium. Okay, so they are not blocked. If there is a change in medium, they are not stopped. They can travel through solid, liquid and gases, all the three mediums. And in these, as they are longitudinal, the particle vibration is parallel to direction of propagation. Means what? There will be compression and rarefaction as you will experience in case of sound waves, right? And so what they will do, they will cause that squeezing and elongation. Means they can cause these tensional forces and compressive forces in the material through which they are passing. So they can cause that elongation and squeezing of the material because of this compression and rarefaction. But whenever there is a change in medium, their velocity will change. Remember that when there is a change in medium, their velocity will change, and their direction also will change. Direction changes. What is meaning of change in direction? That is they will be getting deflected, they will not travel along a straight line, they don't travel along the straight line in case of change in medium. Okay, so See this. Suppose you are considering this is the focus and there is a P wave here. P wave is generated, and see this. This is a mantle, and this is outer core, and this is inner core. So you'll find that P wave is recorded here, it is recorded here, it is recorded at all these places. So this is direct. But once they strike this outer core is in the liquid state, so they get deflected and they may not be recorded in this region. Okay, so they come directly in the lower part, so they get recorded here, and because of deflection they will be absent in this region. So this area is known as 103 to 10 143. This will be considered as the shadow region of the P wave. Okay, shadow region. What is shadow region of P wave? Where the P waves are not at all present, or if at all they are recorded, they may not be directly recorded, or they are recorded with a different velocity. This will be known as a shadow region. So from the study of this shadow region, we can understand that inside the earth there is some change in material. Okay, change in medium. That is the reason they have not arrived here. They got deflected from their original path, original routes, right? So because of this factor, we can say that the interior of the earth is not homogeneous. We can conclude that interior of the earth is what? Heterogeneous. Okay, heterogeneous. Okay. So understand this term and remember that is the shadow region of P wave. Now what about S wave? This is the second type of waves that are generated from the focus. So they arrive after some time from the happening of the earthquake, therefore they are known as secondary wave, or you can say simply that the S waves are going to be recorded after the P waves. They are recorded on the seismograph after some time delay, therefore they are known as secondary. But their important character is they are the transverse wave. What is meaning of transverse? Like L we have discussed, L is a longitude, this is transverse. Transverse means if this is the direction of propagation, the vibration of the particle is perpendicular to the direction of propagation. So this is transverse. So here it is perpendicular to the direction of wave propagation. Longitudinal means this is direction of propagation, this is direction of vibration. Parallel to direction of propagation is longitudinal. Longitudinal was the nature of P wave. Perpendicular, transverse, this is the nature of S wave. And that is nothing but we can say that it is simply like this, like a sine wave which has the crest and trough. Okay, crest and trough. Sine wave which is having crest and trough. ठीक है. But the most important character of this S wave which will help us in understanding this is that they can only travel through the solid medium, they don't travel through the liquid. Okay, means their velocity of S wave is going to be zero in liquid medium. In liquid medium they will be having a zero velocity, right? Their velocity will remain zero in the liquid medium. So these are the waves that can really help us in understanding the material difference inside the earth. जैसे मान लो P waves can travel through both solid and liquid, but they only change the velocity. They can travel through both solid and liquid, but they will change the velocity. So from P wave we can understand that ठीक है, there is a change in medium inside that, but we cannot really say that where it is liquid and where it is solid. But when we are saying S wave has zero velocity in liquid, and based on S waves we can say that where is the possibility of the liquid medium inside the earth. So see this. So if this is a focus here and this is the P wave, so S wave is recorded here at all the places you have recording of S wave, and this is nothing but the boundary of outer core. So they are propagating through the mantle, because mantle is what, liquid, sorry, mantle is solid. But what about this outer core? Outer core is liquid. So when these waves strike the outer core, they will be blocked, they will not be allowed to travel. So this region from 105 to 105 degree, you will find this is known as a shadow region of S wave, where S waves are not recorded, they are not present. Okay, S waves are not recorded, or S waves are absent here. Okay, this indicates that there is some liquid material inside the earth which is not allowing this S wave to move ahead. There is a liquid material which is not allowing this S wave to get propagated. Okay, so this material obviously is what, outer core. Okay, so we got two shadow regions. One is the shadow region of P wave and another is the shadow region of S wave. And when we overlap these two shadow regions, right, shadow regions, we are going to get, or we are going to get an idea that yes, the interior of the earth is not uniform, first thing, and there is some liquid material, and this liquid material can be now understood as the boundary between mantle and core. Okay, so this can be done by superimposing the shadow region, and this is now referred as the seismic probe of earth's interior, right. So this is in this way we can understand this topic for the geomorphology, how we can use. So here what I have done is I have connected between the two topics. One, we are having understanding of earthquake, and second, interior of the earth. It is assumed that you are having a basic understanding of these two topics, and I have tried to link from one topic to other. So in this way it will be useful for you, and hope this topic is clear. You can refer the basic book here, that is Physical Geography by Savinder Singh for optional, and we will continue with another topic in next class.